Hello everyone. Today we will discuss about inter-process communication. So inter-process communication means communication between different processes. So processes executing in operating system can be of two types: cooperating process and independent process. So suppose two processes are executing P1 and P2. So if they're sharing some data, then if P1 is executing, the execution of P1 can affect P2 and execution of P2 can affect P1. Let's understand this using an example. Suppose you and your friend are working on some, let's say, assignment, and you both are sharing some resource, let's say, pencils and your scales. So if you are using those shared resource, let's write it down here. Okay, A and B, two persons A and B are sharing some resource, let's say your stationery. So if A is using the stationery, then B should wait. So execution when A is working, so this execution of A is affecting B because B has to wait because B cannot use those stationery items while A is using them. Similarly, if B is using those stationery items, then A will have to wait. So, and if they both want to work, they will have to cooperate with each other because they are sharing some resource. So they will have to cooperate with each other. And if A is using it, so since A is using it, this will affect B because B cannot use it at that time. And if B is using those items, shared item, then A will have to wait if it wants to use those items, right? So since they are sharing some resource, so they will have to cooperate with each other, so they are known as cooperating. And same thing goes for processes. Suppose if P1 and P2 are executing and they are sharing some resource, so if P1 is executing, the execution of P1 will affect P2, and if P2 is executing, the execution of P2 will affect P1. So a, a process is known as cooperating if it can affect or can be affected by the other process executing in the system. And clearly, any process that shares data with other process is a cooperating process. Now, what are independent process? Now let's take same example. If A and B are working on something, and then A has its own stationary item, B has its own stationary item. So if A is using its own stationary item, it will not affect B because B has its own stationary item. So working of A is nowhere going to affect working of B. Similarly, working of B is nowhere going to affect working of A, because if A is using it, B is using this item, then A has its own item. A will not have to wait for it. A can work normally and B can work normally. They are not dependent on each other in this case. Okay. Same thing goes for independent. Same thing applies in case of processes also. If P1 and P2 are two process executing and they are not sharing any resource, then they will not be affected by execution of each other. P1 can execute normally. The execution of P1 will not affect the execution of P2, and execution of P2 will not affect the execution of P1. So since there is no sharing of data, so so they are independent process. So basically a process is independent if it cannot be affected by the other process executing, or it cannot affect the other process executing in the system. And obviously any process that does not share any data with any other process is independent, because there will be dependency only if they are sharing some data. Then only they can affect or can be affected by the execution of other process. Now if two process wants to communicate, then there are two fundamental models of inter-process communication: shared memory and message passing. So as we can imply from the name itself, shared memory means a region of memory is shared between the two processes. So a region of shared memory is established, and then the two process can read and write from this shared memory region, and hence they can communicate using shared memory region, this shared memory region. Now since the suppose process A and process B wants to communicate with each other, so either process A will establish this shared memory region, or process B will establish this shared memory region. So shared memory requires communicating process to establish a region of shared memory. And now where this shared memory region will lie? So typically the process which creates the shared memory region this shared memory region lies in the address space of that particular process. Now assume that process A has created the shared memory region. So this shared memory region will lie in the address space of process A, and process B will have to attach this shared memory region to its with its address space so that both of them can communicate. Once this is done, then both process A and B can read and write to this shared memory segment, and hence communicate with each other. Now, we all know that there is a restriction that normally the operating system tries to prevent one process from accessing other process memory. So shared memory requires that two or more process agree to remove this restriction, because if there is that restriction, then obviously process B cannot write in that memory region if it is attached with process A's address space. So they have to first remove this restriction, and then they can exchange information by reading and writing in data in the shared areas. Okay, and then the processes are also responsible for ensuring that they are not writing to the same location simultaneously. Okay, now so let's discuss the producer consumer problem. So basically, what happens in this problem, in this concept, there is a producer which produces some information, and that information has to be consumed by a consumer. Now, so basically the producer and consumer are two processes. So if they want, they are communicating, so this communication can be possible using shared memory. One solution to this problem is shared memory. Now, if the two process wants to communicate with each other, like the producer wants to produce some item and consumer wants to consume it, so there must be some buffer of items available that can be filled by the producer and emptied by the consumer. And this buffers will reside in the region of memory which is shared by the producer and consumer, so that both can read and write from that region. Okay, now we are saying that buffer of items. So if we talk about buffer of items, it can be of two types, bounded and unbounded. And also, since producer and consumer are sharing some region of data, so the producer and consumer must be synchronized so that the consumer does not try to consume an item that has not yet been produced. And uh, so basically, a producer can produce one item while the consumer is consuming another. That is fine, but the producer and consumer must be synchronized so that consumer does not try to consume an item that has not yet been produced. Okay. Now moving on to the buffer types. So there are two types of buffer, bounded and unbounded. Now unbounded means there is no restriction on no, you can say, practical limit on the size of buffer. So since there is no practical limit on size of buffer, consumer obviously may have to wait for new items to be produced yet, but the producer can always produce the item, because producer will have to wait only if the buffer is full. But here we have no bound on buffer, so buffer will never, I mean, there is no limitation on size of buffer, so the buffer will never be full. So the producer never has to wait. Basically, the producer can always produce the item, but the consumer will have to wait for new items. But if we talk about bounded buffer assumes a fixed buffer size. Now if you have a fixed buffer size, so obviously the producer will have to wait if the buffer is full, and the consumer will have to wait if the buffer is empty. The consumer will have to wait for the producer to produce something, right? And the producer will have to wait for the consumer to consume something, so the buffer, if the buffer is full, it can be emptied by the consumer. Okay, so that's all about shared memory system. We will be discussing message passing system in next class. If you have any next video, if you have any queries, please drop them in comment section. Thank you.